Hello and welcome everyone. Thank you for joining us today for our webinar titled Enhancing Spark with H2O's Random GridSearch and AutoML using Sparkling Water. My name is Patrick Moran and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Jacob Hava, or Kuba as we call him, is a team lead and senior software engineer at H2O.ai. Before I hand it over to Kuba, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Now, without further ado, I'd like to hand it over to Kuba.
Hi, folks. I hope you are doing good. I hope I'm not interrupting your lunch in US and anywhere around the world. I'll be talking about enhancing Spark pipeline API with Sparkling Water, and mainly this will include our AutoML, GridSearch, and our target encoder APIs. So a little bit about us. It's just me who is speaking right now, but I wanted to mention also Marek. He's my colleague and he's also senior software engineer at H2O.ai, and he helps a lot on Sparkling Water project. And we can also see special thanks to Martin Barus, because he was the one who originally created those slides, and I borrowed them from him and enhanced them into enhance them with Sparkling Water stuff. So a little introduction to our stack. Mostly open source stack. I won't be talking about our closed source products such as Driverless AI and Enterprise Team. So I guess you know Apache Spark if you are joining this webinar. So Apache Spark is analytics engine which can be used for large scale data processing. It's really great for big data munging. It's really flexible and powerful. It's all in memory. And you can also do some basic machine learning operations with Spark using the ML or MLlib libraries. H2O-3 is also open source library. It's also in memory machine learning platform. Compared to Spark, we are focusing only on machine learning. We don't have that much strong data munging features, but we try to really focus on powerful machine learning. We provide algorithms in supervised and unsupervised algorithms, so you can choose whatever suits your needs. And we've also, as I mentioned, AutoML and GridSearch. And the combination of these two tools is Sparkling Water. What we try to do in Sparkling Water is to combine the power of Spark, make use of the powerful data munging features available in Spark, and add users the possibility to use the powerful machine learning capabilities in H2O-3 platform. When I said that, we also try to expose the APIs in Spark-friendly way. That means that the Spark user should learn the new APIs or APIs of H2O-3. It should be really straightforward to transform to switch from Spark ML, let's say, to H2O-3 in Sparkling Water. So the name was obvious when we created the product, I think 6 years ago. Sparkling Water was the obvious name, H2O plus Spark. So little introduction. I saw also on LinkedIn that there was somebody asking whether we compete with Spark. We don't compete at Spark at all. We really try to be library which we give to users of Spark, and we give them the choice to use our machine learning algorithms alongside with Spark ML. We try to be transparent, so where you can use Spark data structures, you can also use H2 data structures there in H2 algorithms. So instead of passing H2 algorithms, let's say our H2 frames, we internally convert them to data. You can pass them data frames, and we internally convert them to H2 frames. So you don't need to worry about the data conversions. But you can also convert your data between H2 frames and Spark data frames manually. We have methods for that. What we can also see is that I'm mentioning that we can also do really nice workflows workflows. What it means that we can leverage Spark pipeline APIs, and we can use lots of predefined stages, or we can write our own stages, and we can combine both Spark or H2O pipeline stages. They have the same APIs, and you can save them on the disk or deploy them anywhere where you want and run productions, let's say, on the whole pipeline. And in Sparkle Motor, we also provide Sparkle Motor can also act as a deployment tool for driverless AI modules. What does it mean? That if you have used driverless AI and have trained some model in driverless AI, you can get artifact which is called Mojo, which can be used for partializing the model. You can upload it to Amazon Lambda, or you can write your own scorer, and Sparkle Motor is one of those scorers. So Sparkle Motor can use Spark platform to score the driverless AI modules. So benefits of Spark and H2O, I'm almost cover all of them. So Spark has really Spark has some additional algorithms which we don't have at H2O right now, such as NLP. As I mentioned, we can also use driverless AI modules, which has support for NLP, but right now in H2O we don't have that great support for NLP as in Spark, but we are trying to catch up. We have also already support for word-to-vec and algorithms like that. But what Spark is really great at is powerful data munging. You have access to SQL queries and lots of predefined methods how to alter your data, and also the machine learning pipelines, which I will get back to later. In H2O, we have the advanced algorithms. Our algorithms are pretty easy to use. We have tuned the algorithms. We have really nice defaults set up for you, but if you want to really take the best out of the algorithm, we expose the really advanced parameters to each algorithm, so you can tweak your algorithm and make the best out of your data. It's fully distributed, so you can start, let's say, 5 H2O nodes, and it will work in parallel on all. The work will be parallelized on all those 5 H2O nodes. We also have graphical user interface, which is called H2O Flow, and we have clients for R, Python, in R and Python. In Sparkling Motor, our client is called R Sparkling, and in Python client is called PySparkling. So how to use Sparkling Motor? It definitely depends on your environment. Some people use Sparkling Motor in Databricks cloud environment. Some people use Sparkling Motor in EC2 on Amazon EC2 or on Azure. The simple way how to start Sparkling Motor is really similar to this. You just need Spark Home available on your machine, and you just need to pass -- packages and specify Maven coordinates of Sparkling Motor package. And that will ensure that your Sparkling Motor classes will go into your Spark application, and you can start Sparkling Motor. So I already mentioned that we have 3 clients in Sparkling Motor. For Scala, we just have Sparkling Motor, we call it like that. In Python, PySparkling. In R, Sparkling. We try for these 3 clients to be unified, but R Sparkling is a little bit behind, but we are trying to catch up. So right now I will cover 3 use cases, how Sparkling Motor can be used. Then I will go to AutoML, GridSearch, and Target Encoder, and I will finish up with simple description of how we can deploy H2O module or our model. I will just do this. So when we can use our one use case how to use Sparkling Motor is that we use Spark for data munging. Let's say you load your raw data, and we use Spark to clean the data. For example, using the SQL queries or anything what we are familiar with. Then we convert the data from Spark to H2O. We can do it manually using H2O frame method, and we can run any algorithms which is listed here and any others, or we can also use our Sparkling Motor API, which does the conversion for you, and you don't need to worry about that. So you will run, for example, like H2O GBM, and you will pass Spark data frame to it, and our Sparkling Motor will handle automatically the conversion between Spark and H2O. And then for the prediction, you can process the predictions in H2O and in Spark. The advantage of using also Sparkling Motor for doing the modeling and doing the prediction is that we are utilizing the H2O modules. What it means is that in H2O you can train the models in two ways. When you train the model in raw H2O, you always train binary model, which depends on the runtime of H2O, and you can export mojo out of it, which is a runtime independent artifact which can be used for scoring. And in Spark Encoder, we always store the mojo. So whenever you train the model, you no longer need H2O to be running, and you can deploy the mojo anywhere. The another advantage is that it's not version dependent on H2O library. So the mojo it's backwards and forward compatible with H2O versions. So you don't need to worry about it as well. The other use case is very similar, but we can just see that we can do data munging in H2O as well. One operation which we have in H2O, which is really powerful, is our join capabilities, which were written by Matt Dowell, and what it means that we can do really fast joins on really big data sets when it comes to millions of rows, and we can do that really fast. I won't mention any specific numbers, but we have benchmarks, public benchmarks on our webpage, so I can point you to that later. So that's, for example, one reason why you might want to use some H2O data munging features, even though Spark has more of those. And the last use case, which is usually the most common, is that we have our offline model training pipeline where we use Spark for data munging. We do the modeling in Spark Encoder, and we export the mojo. It's done when you train the model. You automatically get the mojo. You don't need to worry about that, and you can deploy the mojo in your online processing pipeline. So let's say you want to predict some online events when user clicks on something. What will happen? What will be the outcome? That's your online stream processing pipeline, and you can do the same. You transform the data using Spark, and then you pass the data to the mojo, which will do the scoring and gives you the result. Another this is wrong slide. I already mentioned a few times mojo. So what does it? I would like to put that in the bigger scope. We in H2O have actually 3 ways how to productionalize our models. The original one was Pojo, which is shortcut for plain old Java object, and it means that we store the model as Java object. And in these cases, we hit several limitations. For example, in big tree-based models, we exceeded Java limits for, let's say, class file size and number of variables defined in one class and so on. So we decided we need to do something better. So we came up with Mojo, which stands for Model Object Optimized. And that's right now how we store Mojo models in H2O-3 and Spark Encoder. And as I mentioned, it's not version 2. It's not tied to H2O runtime. It's not version specific. So you can use it with newer version of H2O or older version of H2O. The same holds for Spark Encoder. And also, it's not Java based. You can think of that as a XML file or YAML file describing the model. So we don't hit the Java issues anymore. When it comes to driverless AI, we have the Mojo pipeline, which is specific Mojo, which comes from driverless AI, and it's not just Mojo, which consists of one single algorithm to be scored on, but it can also contain additional feature transformations which come from driverless AI. Also, you don't need any dependency on H2O or driverless AI frameworks when you do scoring in Spark Encoder on Mojo pipelines. So that was a short introduction to Spark Encoder and some concepts which I will be needing later during this talk. And finally, we can jump in and start with the pipelines. So I hope you are a little bit familiar with Spark Pipeline API, but let me summarize it a little bit. So in Spark pipelines, they consist of 3 main elements or 3 main concepts. One, let's start with pipeline here. So pipeline is a wrapper around stages. With the stage can be either transformer or estimator, and those stages represent data manipulations. And you can define pipeline which will consist of, let's say, n stages, 5 stages, and when you run fit on that pipeline, it will go through each of the stage, and it will run the code inside of each stage. Now we have two kind of stages. We have a transformer, which implements the transform method, and it's usually good for transforming your dataset from one state to another. Let's say you have one column with string representation of date, and you want to create new 2 columns, year and month. So for example, that transformer can take that dataset with that string column and can create new dataset with the original column and 2 additional columns, date, day and month. There is a lot of predefined transformers for that in Spark, such as tokenizers, stop words remover, bucketizer, and so on. We also have some transformers defined in Spark and Motor, such as column pruner, which removes specified columns, and so on. The other stage, which is called estimator, it implements the method fit, and this estimator stage is good for wrapping the models. So let's say when you want to train H2O-GPM or H2O-XGBoost or Spark linear regression model, you use estimator. That estimator will implement fit method, which will fit the model on the data you pass to it, and the outcome of this fit method is actually transformer. So when you actually run fit for the first time, you will get transformer, and then transformer is again part of that stage, because the output of the fit is transformer, and the transformer is just representing scoring on the model. So again, scoring is just changing state of dataset from state A to B to so that's the estimator. And we can use estimators for all the algorithms in H2O and all the algorithms in Spark as well. So how does it look on pictures? I just wanna I will be working with few algorithms in this talk, so I'll just want to quickly introduce them. I'll be talking about generalized linear models and GPM models, tree-based models, XGBoost, and random forest. And we also have support for deep learning in Spark, AutoML, and also DR, also other models such as never mind. Basically, all the models available in H2O should be exposed in Spark and Motor. So finally, how the pipeline API looks like. I'm using PySparkling, Python code. You can do this in Scala as well. The API is completely the same. So we can see that I just need to import I just need to do few imports, importing PySparkling, importing transformers from Spark. And on the line with H2_GPM, you can see that I'm defining H2O-GPM estimator, Spark estimator. I'm giving it seed 1 for reproducibility. I'm specifying features columns. You can pass their array of feature columns, or one or as many as if you want, and you specify also label column, which is the target column or response. So that's how I can specify the Spark and Motor algorithm stage, estimator. I'm also doing really super dummy SQL transformer stage. You can see that I'm selecting everything from current dataset. It's completely useless. It doesn't do anything special. It just selects everything what was there before. But I just wanted to show you how you can combine stages from Spark and H2O or Spark and Motor. So I'm defining here a SQL transformer with the statement above, and below I'm defining the pipeline, and I'm specifying both stages, H2O-GPM and rename stage. Then I can call the fit method on the pipeline, and what it will do, it will go through all the stages. So it will first go through H2O GBM stage and then the rename stage. Once I call the fit method, I'll get model. The model in this case is actually a pipeline model, and it contains all the stages. When you run the transfer method on the pipeline model, we will go through all the stages defined in the pipeline, which is actually perfect for productionization because your code is now you don't need to worry about writing two different pieces of code for training the model and deploying the model. You can always your data scientist can always train the model and give this to people who actually deploy the models, and the code is same. So it actually simplifies deployment a lot. I'll be also when I'll be talking about GridSearch AutoML, I'll be mentioning also how we can specify cross-validation and validation. So I'm sure that you are aware with what validation and cross-validation is. In short, when you want to do what validation means is that you split your data set into two or three splits, where one split is used for training the data set, and we validate the data set against the validation data set. And we can also have the test data set, which is used for final evaluation. What is actually bad about validation is that you lose some portion of data because you can for validation and test data sets. Cross-validation is actually fixing that. We split the data into, let's say, k-folds, and we will do k-fold cross-validation, which means that we always select we will always select k-1 fold, and we will do training on them, and we will use the remaining fold for the prediction for validation. So finally, GridSearch. Why we would actually even try to use GridSearch in Spark and Water and not just from Spark? Spark GridSearch, it has a grid. There are two different layouts which GridSearch can actually use. There is a grid layout which actually goes through the parameters in like deterministic approach, which is good as deterministic, but it can take a lot of time when you have really big hyperparameter space. There is another approach which is called random layout, and we try to search the hypersparse parameters using the some random techniques. Spark has the first approach, but it doesn't have the random grid search. So that's why you might want to use Spark and Water for getting better performance and using grid search. As I mentioned, in Apache Spark you have a cross validator, which is Cartesian GridSearch, and it does cross validation. And there is also the train validation split, which is Cartesian GridSearch, and it's using the validation and training dataset. In GridSearch, in Spark and Water, we don't have two different APIs. We have one single API, which is called H2O GridSearch. You can limit the number of maximal models. You can limit the number of minutes, how long will GridSearch run. We have Cartesian and Random GridSearch. It's just a matter of setting one option, so you don't need to remember two different validators. And you can also specify cross-validation or training or validation split yourself in the same H2 GridSearch. How does it look in the code? We can see that I have also a few imports here. I'm specifying the hyperparameters, which are called GBM params. And below, at the end of the slide, I can see H2 GridSearch stage. I'll be doing GridSearch on algorithm H2 on GBM, H2 GBM. I want to do cross validation, so that's why I'm specifying n folds to 5. If I wouldn't like to do cross validation, but I would like to use simple train and validation approach, I could use, instead of n folds, I could specify split ratio param. And that split ratio param accepts one number, which is how much percent I want to give to trained data set, and the remaining percent I will give to the remaining percent I will use for the testing validation data set. I'm specifying the hyperparameters here. I'm also specifying the label column. You can see that I'm specifying the strategy, which is random discrete. If I would like to use Cartesian, I would just write here Cartesian. So no need to change the research. It's just a matter of configuration. I'm saying research that I want to train maximally 10 models, and then I want to end. And you can also select the metrics which you want to use for selecting the best model. So for example, here I decided that I want to sort the models based on RMSEE. You can also use different matrices, and our GridSearch is smart in a way that when you specify the metrics, it will sort the models according to the metrics ordering. So when for example in one matrix the higher the better or higher is better, in some matrix it's otherwise. So our GridSearch is aware of that, and it will always give you the best models according to metrics ordering. And I'm not actually specifying any pipeline. I'm calling fit right directly on our GridSearch stage right away. So you can see that I actually can call H2O GridSearch fit, and I will get H2O GridSearch model. This model is Mojo model, so I can take this to production. I don't need H2O to be running anymore for this model. And you can also see that I'm not specifying any, I'm not working with any H2O data structures. I'm just passing it Spark data frame. So I really like, what I think is really helpful is that you have all the configurations in one single H2O GridSearch, and you can tweak it as you want. On our GridSearch, you can also call methods such as get parameters or get hyperparameters, which will tell you which hyperparameters were used during the training. So actually, when you call that method, you will get Spark data frame, which will consist of Mojo model ID and all the hyperparameters which were specified and their selected values. And then you can again use if you are not satisfied with the first model which our GridSearch gave you, you can always pick one of the models which were created during the GridSearch process as well. So AutoML, what is AutoML? AutoML is when we were talking about GridSearch, it's just we are just using one algorithm, and we are doing hyperparameter search on top of that algorithm. In AutoML, we are actually using all the algorithms which make sense to use. So we can try to train XGBoost, GBM, deep learning, and then we select the best out of the models. So we are not tied to one algorithm. And the one important approach in AutoML is stacking. And Spark Motor and AutoML is using stacking heavily. What does it mean is that we actually train L-based models, let's say simple models, and we combine those models into one meta learning model, which is actually more powerful than those L-specified base models. How does it work? When we train Ensemble in H2O or Spark Motor, we always use K for cross-validation, and then we combine the predictions into frame on the meta model, and we train the meta model. Predictions are done also very similarly. We have models, we run predictions on those base models, then we combine the predictions into dataset, and we pass those predictions into meta model as input, and we give the output is the ultimate prediction from the meta model. So as I mentioned, H2O AutoML is using cross-validation. You can also specify that you don't want to use cross-validation AutoML, but usually we get better results when we are using cross-validation. And we are training the models from different families. So algorithms from different families. So we are training GLM, GBM, XGBoost, and then we always stack the models into approaches. Is it here? No. So I'll just talk about it. So we always take the best out of each family. So let's say we get the best model from GLM, we get the best GBM model, we get the best XGBoost model, and we stack those best models. And usually this stack ensemble is the best model found by AutoML. So how does AutoML API looks like in Spark and Motor? It's very similar to H2O GridSearch. I'm using seed for reproducibility. Again, I can specify a label column. I can specify max runtime sex, which limits number of seconds how for AutoML run. You can always specify maximum models. And I can also specify ignored columns if I know that ID column is not helpful for me. I can also specify ignored algorithms if I know that I don't want to use XGBoost. I can ignore that algorithm. I can tell that to our AutoML, and you can also configure AutoML that you don't know. For example, keep cross-validation predictions. We just throw them away, and so on. Training the model is again really simple. Just calling the fit on data frame, and you get AutoML model. You can also get leaderboard from AutoML, which is not on the slide. But what AutoML leaderboard is that you get actually nice representation of the models which were trained during the AutoML process, similar to what I showed you in GridSearch. It's actually a data frame where you can see all the models which are trained during AutoML ordered by the performance of the model. What was AutoML? And the last stage I want to talk is target encoding. Target encoder is in Spark Motor almost for about half a year. And I think it's really, but I couldn't follow a really nice and simple way how to do this in Spark, so that's why we decided to expose this in Spark Motor via H2O-3 target encoder method. So how does it look in PySparkling? Again, here I'm importing H2 target encoder. I'm specifying input columns and label column. What does it mean that the capsule column is usually categorical, and I wanna target encode this column into multiple columns to continuous features. And so I define myself here target encoder, and below I define myself H2O GBM, and I can use the output columns of the target encoder. So I will use for example one hot encoded features inside of our H2O GBM, and I will create pipeline which will use the target encoder and GBM. And whenever you run pipeline fit, it will first target encode the features, and then it will run a model on those features. Here we can see how it's called. I can call pipeline fit on the training dataset, and on the final model I can call pipeline model transform testing data frame, and I will get myself predictions of the GBM model with the previously target 100 encoded features. It's also easy, the code below, you can see that it's also easy to export the model. You can call pipeline model save, and you specify the path for storing the model. You can also load the model, which is nice that you can store the model, let's say, into your database or to some model storage and load it again later. So that was 3 ways how we can extend Spark APIs using Spark and Motor, really in short. But all those stages they ended up with model. It was either GBM model, AutoML model, GridSearch model, or in the last case it was pipeline model, which consisted of the target encoder and GBM stages. What these models have in common is that they are actually Spark pipeline models, and internally they are using H2O Mojo for productionalization. So how we can productionize the whole pipeline in Spark Composer? It's really a few lines of code. So again, I'll be demonstrating that on PySparkling. So first, you can think of this that I started myself a fresh PySpark shell, or I'm writing myself a fresh script. So you first need to make sure that you have Spark running. You can disable the lock level. Then I need to just do some technical call, which is actually not required on the new Spark Motor versions, but previously it was required because we needed to load Spark Motor classes into our PySpark application, but it is done automatically right now, so you don't need to worry about the load sparkling jar step anymore. And I'm loading the pipeline. I'm loading using the call pipeline model.load. I'm loading the pipeline model from the location specified by the argument. And what it will do, it will load the whole pipeline, Spark pipeline model. I'm also defining myself a schema, which is helpful because I know the schema of the dataset I'll be doing predictions on, so I can prepare myself a schema. And just now using the following 3 lines, I will start doing predictions on the model I just loaded. So first, what I need to do is define the data source of the data. I'll be using the Spark streaming API for it. So I'm starting the reading stream. I'm specifying the schema, so Spark will be already aware of the schema coming from the data from the data, and I'm specifying the location via the .csv. I'm pointing to S3A, and I'm pointing to bucket H2O World San Francisco streaming data. And what this code actually does, it will periodically check whether there is a new file in that S3 bucket on Amazon, and when there is a new file, it will load it and it will load it. Another line of code is actually doing transformation on that input stream. So whenever there is a new file, we actually do the pipeline transformation on that data set, which just appear in that bucket. So if it's simple pipeline, it will just do one stage. If it's a little more complex pipeline, we will do n stages during this call. I can also store the output somewhere. In this case, I'm just writing to memory to the table called Spark. You can also write the output back to S3. You can write the output back to HDFS. It's up to you. So you can actually see that in this code, I just used one method call to load the data set, which I tried previously, let's say, using AutoML. So I didn't need to worry about tuning the algorithm, tuning the right parameters. I just specified the schema, and using those 3 lines, I was able to bring the code to productionize the code. So that's actually what I wanted to talk about. We have some upcoming features in Spark Composer. We are finalizing our support for Kubernetes. Our community is already trying that. We are also trying to support dynamic allocation in terms of H2O on demand. So what it means that when you will, for example, be training H2O AutoML, we can see how the dataset is big, and based on that, we can start dynamically number of H2O nodes based on the size of the dataset. So we can actually we can compute the model fast and without out of memory issues. So that's our big effort right now to stabilizing and supporting dynamic allocation in Spark Composer. There is some more information which you can actually where you can get more information about Spark Composer or H2O. We have some videos. You can see our old meetups. You are always welcome to use Stack Overflow. We just use Stack Spark Composer or H2O, and we have also Gitter for Spark Composer if you have some questions. If you have some code suggestions, or you found a bug in Sparkling Motor, it's an open source product, so just go to Sparkling Motor on GitHub and submit issue, or even submit the PR. We welcome PRs from the community. And that's basically it. So I hope it gave you something. There's always more to talk about, but I think this might be a nice start for Sparkling Motor, or how AutoML can be used or GridSearch easily in our using our APIs. So if you have any questions, I'll be happy to answer those. Let me just go to the question. Okay, perfect. So I see a few questions here. So let me go through them. The first question is, do you happen to provide support any model exchange format that Spark doesn't? So I will try to interpret the question in a way that do we support any algorithms which Spark doesn't have? Yes, we do have algorithms which Spark doesn't have. For example, we have we implemented XGBoost in a real native Java way in H2O, and right now we are exposing that to users via the Spark Motor API. I hope that answered the question. If not, please just submit a GitHub issue or write me an email or use the Gitter, and we can always discuss it there. Thank you. I missed a part of the presentation. Yes, the webinar is recorded, and you will get the link to the presentation with the slides as well. Is there support for a more complex cross-validation setup than a simple k-fold random split, something like cross-validation classes? That I'm not aware of. Right now in Sparkling Water, we just exposed the k-fold. It's possible that H2O has this advanced cross-validation method already available, but we just didn't expose it yet. So I will need to check with the H2O-3 core team. So the answer for this is we don't have that in Sparkling Motor. It might be in H2O. If that's the case, it's simple. It's really simple to expose, and we'll do that quickly. Do you have a tutorial how to integrate Sparkling Motor existing Spark cluster and execute here? And does Sparkling provide deep learning models as well? Yes, we do provide deep learning models as well using Sparkling Motor API, and our model is called H2O Deep Learning. And we have in our code base we have integration examples how you can integrate existing Spark applications with Sparkling Motor. So you just need to go to Sparkling Motor GitHub repository and visit the examples sub-project, and there you will find README with all the examples how you can use Sparkling Motor, even the deep learning. Another question is, how can I map our data frame in Spark to extract raw data and make predictions using H2O module model? That's really a question which would deserve some code to be shown. It's definitely possible. You can do that. You can do this. But what I would like to stress out, if you are using Sparkling Motor API, there is no need to do this. We do that internally, and we try to be smart about that. And we try to also optimize the code. So if you use H2, if you use the APIs I showed you, you don't need to worry about manually mapping our data frame, extracting raw data, and doing the predictions. We do that automatically. So if you do pipeline model.transform, all this is done for you automatically. But if you are still interested how we do that, just go to Sparkling Motor GitHub code, Sparkling Motor GitHub, and go to H2O module model class, where you will see how we do that. Can I use Scala Spark in place of PySpark? Yes, absolutely. Scala is our first citizen in Sparkling Motor. It was the first API we implemented. The second was PySpark, which is now fully compatible. And now we are trying to make R sparkling also compatible with what we have in Scala and Spark. Is there any duplication of data when we transfer data from Spark to H2O? Yes, that's also a good question. There is some sort of data duplication, but we need to think about that. It's not like it's not full copy of data set, because when we convert data from H2O to Spark, we do that in lazy way, and we just extract the row, we just extract the columns and rows which will Spark actually need. We are using the Spark catalyst and underneath. So when you are converting H2O frame to Spark frame, we are just extracting specific columns and specific rows, and we are doing that in lazy way. So in this direction, there is no data duplication. In the other way, when we convert data from Spark to H2O, there is sadly some data duplication because we need to convert that to our internal structure. I see that some for few more questions appeared, and we still have a lot of time. So is it more memory intense compared to ML cross-validation by modeling? I'm not myself really a deep data scientist, so it's hard for me to answer that. But H2O and Spark Motor is really in-memory machine learning platform, so it's using everything for memory. I don't know how ML cross-validation is working, so sorry about that. I can't answer that question. I'm new using AutoML. I never used H2OML. So which models estimators the AutoML uses from that library? Our AutoML is using deep learning, GBM, XGBoost, random forest. It's using stacking for stacking the models and so on. So basically, we try to use the whole palette of algorithms from our available algorithms in AutoML to give you the best model. Do you have support for Shapley value and Sparkly R? Yes, our R sparkling integration, our R integration based on Sparkly R is called R sparkling, and we support Sparkly R. And you can also extract Shapley values in Spark and Motor. In Scala and Python, you can do this in a real nice Spark API via the Spark API approach. In R, you need to use the H2O API, but we are working on making this R sparkling API consistent with what we have in Python and R. When should we use Spark and Motor as a Spark Databricks as AutoML and ML flow now? Basically, the answer is just have a look on our benchmarks, which are open source, and we are also running benchmarks with other products. We are submitting papers, AutoML papers, which are reviewed by other folks from other companies who have different AutoML tools, and that's probably the good starting point. Just see how our AutoML performs. The other reason is that actually in this talk you saw how it is easy to use AutoML in Spark and Motor. So that might be other point. There's no need to specify to configure anything. Just few lines, and you have yourself a model. And I think that's it. I'm really sorry that I wasn't able to answer some data science related question, but please ping me on GitHub, and I will forward your question to the right folks in H2O, and we'll get you the right answer.
Great. Thank you to Kuba for taking the time today and doing a great presentation. I'd like to thank everyone who was able to join us today as well. The presentation slides and the recording will be made available on BrightTalk in a few hours here. So we hope you have a great rest of your day.
Thank you.